So good afternoon, everyone. I think fantastic to see so many exciting architects, such a lovely architecture discussions happening over here. I've been enthralled to see all of this. Quite a lot of learnings, not just for all of you, even for us. So I think, the way we started out from discussing about the architectures, right? We've spoken about that. There was a great session from Raji, a lot of learning from him. There was a discussions from the other panel, which was for about RSA, which is really very, very important. And then we also, have some sort of a golden thoughts and unbelievable, sharings from Dr. Pallab Saha from Open Group. And he has shared some sort of stuff that, what does it take to create an really enterprise architecture for a government where there is no failures as such. So a lot of learnings as such. Now, as we move forward, right, what is more important for all of us is to architect for tomorrow, right? Of course, as an enterprise, when we are building up, there is certainly no chances that we need to embrace. So there are a lot of plethora of technologies which are bombarding, and each of these technologies are also coming with a lot of new stuff, right? From and it's a confusing state for a lot of people and a lot of architects, especially for aspiring architects. And one of the mantra that I always give it out for all of us is that, during these all ChatGPT days and others, we need to be agile in learning. And in terms of it, right, we need to learn, relearn, unlearn so fast that there is absolutely no way that we can do. But again, when we develop a systems and develop an architecture, that needs to be done at least for a due course so that it can be created based on composable architecture and all of the stuff. Now, when we started thinking of architecture for tomorrow as a discussion, there was a lot of stuff that we done. The subject is so big, right? Talking about AI ML systems to talking about low code, talking about apps development and all of those. I thought that maybe, we have such a star-studded panelist that we should utilize these all stuff and start taking out one by one. So before I started talking about the architecture and all of those, I think, the first question that I thought that we should definitely ask for, get it resolved for you as an architect is, what are the current skill sets that an architect should possess as part of the stuff so that he can really, embrace, develop the architecture for tomorrow. And I want to have the experts views coming from, Priya, let's start with you. You sharing it out. What does it take? What are the skill sets to become an architect right now? And how you can, embrace it out for the changes for tomorrow?
Yeah, thank you, Nishit.
Yeah, you go.
Am I audible?
Yeah.
That's better now. Thank you. Very loaded question, if I have to start with it. And I come with probably a different kind of experience compared to what my fellow panelists have here. I come from services background. I've been doing this for the past 20-25 years and worked with multiple segments of customers, and I'm a CTO, so there's a lot of technology offering aspects, and what do we focus on for the next year, what are our customers looking at for next years, what are the strategic players in the industry looking at for next year. What you all are expecting as an answer to this question is what I'm supposed to deliver to my customers on a regular basis. And incidentally, we used to do it as a 3-year plan earlier. Now it's become yearly, and every year the technology landscape changes. What is it that we are going to offer to our customers from a technology landscape perspective, architectural aspects perspective changes every year. And so just to summarize it all, what should be the focus for aspirational architects for the coming years to embrace the technology changes and the nicheness that's going to come into the market? There are 3 things that I would like to say based on my own experience. If you are focusing on, first aspect is definitely completely align yourself with a particular domain, because that's what the industry wants. Gone are the days where it was tech focused or tech agnostic or industry agnostic. Now your cloud platforms are getting verticalized, AI is becoming verticalized, data ops are getting verticalized. So aligning with one particular business domain is very important, because accordingly the deliverables would completely change. That's something that I would say is very relevant. And then become good at the horizontals. For example, one of the horizontals that's going to rule for the next couple of years is automation. As much automation as possible. your development, coding is getting automated, your testing is getting automated. So automation anywhere, very key focus on automation is very critical. And a third aspect that I would definitely want to stress on, and the last one is security. Data privacy, security are of paramount importance to every industry today, and the money that organizations lose in terms of ransomware payments is running into billions of dollars. So built-in cybersecurity at all levels, and every architect, if you have to be an enterprise architect or a technical architect, very, very important is that you have very good insights of what cybersecurity is, data privacy is, and that it's built into all cycles of your development or architecture or product engineering. It should be part of all layers of what you do. These are three areas that I would say are very important for you to stay ahead of the curve for the coming years.
I think very valid points, and and what you will see in the panelists is that you will see that different perspective about it, and I'll let Vijay answer that now from his perspective, that what does it take in this technology involving landscape? What are the skill set that we want our architects to have?
Yeah, sure. Yes, I think Priya covered a lot of the functional aspects, which I think are very, very important. What I often tell principal engineers and architects at Swiggy is there are a bunch of leadership and soft skills that are just as important as your functional skills. So for example, we have this exemplary practitioner as a theme for architects, which is that you want to avoid the Averi Tower syndrome, where you're looking at things from 30,000 feet and trying to give opinions. So we expect all architects to be hands-on, writing code on a weekly basis, doing code reviews, and producing artifacts that are exemplary. And what we mean by exemplary is that they are bar-raising for the organization. So if there is a new piece of technology, a new design pattern you're adopting, say for example GraphQL, so the architect is actually driving the organization forward by not just talking about GraphQL, but writing the very first implementation of GraphQL in the organization. So this is what we call as exemplary practitioner. The other phrase that we use is pragmatic and balanced. See, one hard balance you need to be able to walk is between lofty long-term design objectives and being able to make the right trade-offs for short-term objectives. Because at the end of the day, software needs to ship. And that means that you need to have the skill to know what battles to pick, when to pick them, and how to tackle them, right? So this is what we call as pragmatic and balance, which is that you have this touch of pragmatism when you are opining on things on the technical direction you're trying to take. The last, probably the most important one, and this is true even if you're a 30% startup or working one of the FANG companies, is what I call as influence without authority. Which is that if you're going to drive the organization in a certain direction, you need to have the skill to be able to build the trust and credibility, so you're able to mentor a fairly large segment of engineers in a certain direction. Most technological changes are cultural changes in the organization. And if you realize that it's not just about going from tech A to tech B, you're driving a cultural change, then you have the skill. So I just wanted to touch on some of the leadership and sort of soft skills as well that are important.
Great points from you, Vijay. Srini, you want to share your thoughts?
Couple of things. Has been an architect all my life and later being an entrepreneur. Two important things in life. What's the role of an architect? There's a problem you have to solve. What are the building blocks for solving the problem? Raw material, right? Just like a civil, you have cement, steel. Things don't change so fast. Digital world, the raw material changes very, very fast. So you need to marry your business requirement, the raw material, which is continuously changing. Underneath is simply zeros and ones. But with simple things, 0 and 1, there's so much complexity out there. How do you entangle the business and customer problem with the raw material, with the right science of, right type of skills? And to solve these problems, what is important is, you need to build a team which has problem-solving skills. Very, very important. Often you see in the organizations, okay, I want to use certain technology. I think technology should be a building block. You are here to solve a problem. Not to become not to be called as Java architect or a DB2 architect. No, you're here to solve a problem. So you have an enterprise or a customer, you have to solve a problem. So problem solving skills need to be encouraged. That's what you build, right? Great systems are built by, solving complex problems in the most elegant way. So just like powers that talked about, Burj Khalifa or a Taj Mahal. Today we are building, historically we had 7 wonders of the world. Today we have digital wonders. I can just take Aadhaar, UPI, CoWIN as digital wonders, and they're abstract. That's why we need people, thinkers and problem solvers to, and then build the capability in the organization, right?
Yep, I think well covered. So, just in a nutshell, if I can say, apart from the technical skills that you all should have, what is more important is to have the soft skills, which is very, very important in terms of communication, thought leadership and all of those. And the other thing is the business oriented skills, which is again very, very important, which is more revolving regarding, some of the pointers that what Vijay and Srini has said. But one of the other things that I come from my side is the stakeholder management, right? I think that is again one of the critical stuff, right? Problem solving stuff, which is again very, very critical. So in order to solve all of those, so you need to have 3 skills, of course, right? Domain skills, functional skills, that what, Priya has covered. We also need to cover about soft skills, and also needs to cover about the, the business skills that needs to be taken care of. Let's go to Srini.
Sorry to interrupt. Before we jump to the next question, let me give an architecture perspective to these skills what you're talking about, right? We all like architecture, and from morning we have been seeing different blocks. So in my view, I would put this whole skills into 4 building blocks. So one is the domain skills, which people spoke about. Next, I would put the technical skills. And then third, I would put the methodical skills. And fourth, I would put as social skills. Now, among all these 4, technical skills are the ones which change quite rapidly. So one need to focus on the methodical and the social skills, because I think I heard Srini talking about the problem solving, whichever situation you are going to put into, because these problems vary for us to tackle. So if you have good methodical skills, you will be able to find your way out. And the social skills, I think we heard RSA, or basically be empathetic, then you'll be able to connect with stakeholders and find solutions for you. Just, Nishit, I thought I'll give the architecture view of the whole skill perspective, yeah.
Yeah, of course.
Being very, very cost conscious is also very important.
So I think these are the skill sets that will evolve over a period of time, but I think we are in the AIs of the world. We are in the AI economy kind of a thing, right? So, how does, as an architect, right, and this is question to you, Srini, how does as an architect, right, when you have seen these technologies, I'll not call it as emerging technologies, right, but, things like AI stuff has been, pivoting and embracing the stuff. We have everything as GPT coming out, right? Chat GPT, then, Auto GPT, and all of those, right? Every next 2-3 alternate days, we have new GPTs coming out. And of course, new business models needs to be coming over a period of time. How does, as an architect, how does your enterprise embrace these sort of changes, and what are the stuff that you need to take care of?
I think that's a good question, Nishit. I think I relate this to somebody who was asking the previous panel discussion, the technology is changing quite fast. So how should business react to that? Should every business go and adapt, or is it making sense or not? Or if I come to the architect's perspective, an architect should not end up like a kid in the candy store. You go out there are a plethora of options available, technologies, and what do I do? So Nishit, for me, everything goes back to the purpose, right? So for what am I architecting for? What is the problem I'm trying to solve? So that's where I would come from. That for me, when there is a technology which is trying to push the boundaries or the envelopes to what you could do, there is another dimension which we typically call as market pull. So this happens when an industry experiments the technology and proves that it makes sense, it can alter my value stream, or it can help me to create a new, let's say, type of service or a new business value, then the technology makes sense. Typically what happens is we remember all those technologies which are really creating value and making sense, but we quickly forget those things which go through the hype cycle and then quickly die down. So which are those things which are going out? Because they're really making value, creating value and making sense. So in all these technologies, we can hear a lot of hype about ChatGPT. We can say, ChatGPT had probably a few million users in a couple of weeks. But what next? What business sense it makes? So for me, the purpose comes in the center. And I would say the role of an architect who is sitting here is to use the right technology for the right purpose in the right form with the right intent. That covers all attributes what we spoke about. So for me, this is the guiding principle lens with which I would look at when there are a whole lot of technologies available to take my decisions, what fits the problem which I'm trying to solve.
Right. The other point that I can say that, the one single thing that actually changes the entire dramatic is all about trust, right? The way we transact, right? Any of the transactions can't be done without trust, right? If we are searching, for example, the likes of Google search or Bing, right, to get the data, we are, relying on it. Or even we are doing some sort of a retail shopping, right? So we are expecting that that particular retail company is going to, deliver it out. It's all about trust, right? Now imagine, and I'm not going to name some of those companies, but imagine, right, when you are building stuff, right? There was great example of, stuff that, earthquake in Japan that, earlier Gopi has mentioned. But think about it, when you are ordering something from Amazon or Flipkart, right? And when you click on order or place your order and it doesn't get order, I think you don't actually blame Flipkart and AWS. You actually blame yourself. That maybe the internet connection might be different. You started looking in your area, because that's the trusted stuff that has been created over a period of time, over the period of years. So when you are architecting the systems, I think you have to create a trusted based architectures. Now, when you are creating a trusted based architectures as such, there are certain architecture that has still becoming very, very relevant from the age from 2000 till even now, right? We talked about microservices, right? And a lot of you guys are also playing about microservices as part of it, right? Now my question to Vijay is, right, how is microservice playing the role in terms of a modern software architecture stuff, right? And how can these architects really leverage it out to create what we called as RSA enabled or, really sustainable kind of a development, right? Your thoughts, how you are doing it at Swiggy.
Yeah, I think there's just a lot of public literature out there on microservices, and it's a generally well-recognized paradigm. But what we saw over the last 4 years at Swiggy is that there are some interesting challenges that companies face when they are migrating from monoliths to microservices. The first challenge is even trying to define the boundary for a microservice. Oftentimes teams tend to swing between a monolith and a nano service, and the place you don't want to be is what I call as a distributed monolith, which is the worst of the two worlds. You don't get the agility of microservices where you're able to independently design, test and deploy software. Any small feature change actually requires you to make changes to multiple services. So we use some clarifying questions, and I think Srinivas talked about being grounded in what problem you're trying to solve. So we actually use customer backward thinking, which is CBT, sort of a common term that says, for a given microservice, are you able to sharply answer this in one sentence or two? What is the purpose for this from a customer backward lens? For example, customer, as you are saying, is able to place an order, for example, right? The example you mentioned. And you start with that. It's the simplest way to actually articulate a problem statement. And then from there, you look at entities and operations it owns. The problem is we sometimes start tech forwards, right? We say that, in my mind, I've made up that this is the boundary for a microservice. And the telltale sign that you're going in the wrong direction is when you have to share state. So as one example I commonly give is that one of the payment systems back when you're building ended up building a separate microservices for refunds and for charges. Charges is a forward transaction, it's called a charge. The problem is that you have made boundaries based on verbs, not nouns. And what happens is that the refund leg has to consult the charge leg to know whether the transaction actually happened or not before a refund can be issued. So these are some very common pitfalls. The second pattern that I see is around resiliency. You talked about how do you make systems resilient. See, in this world, a simple customer-facing operation like clicking place the order typically involves, so we operate about 400 to 500 microservices in production. A simple operation like add item to cart, for example, could involve tens of microservices. So the question then comes, how do you isolate faults? Because one common problem with microservice architecture is this cascading fault, which is that you start with a service that is almost browning out, and the rest of the microservices participate in actively taking it down. Now again, there is a lot of literature on how to use circuit breakers and retry. And the problem is, in practice, this is a hard thing to get. One pattern we use, this was popularized, I think, by Netflix in one of the engineering blogs, is called adaptive resilience. If you're not familiar with it, I would encourage you to take a look at it. It's a different way of managing resilience in a microservices architecture. Traditionally, you try to sort of divvy up your budgets and look at timeouts and things like that, which is very, very hard and impractical. It kind of works on paper, but never in practice. But yeah, these are some of the challenges that I foresee and the solutions we developed.
Perfect. I think then practical examples is what really is important for the audience as well. So thank you so much, Vijay. Srini, you want to share your thoughts from it?
Couple of things, I've seen, the old assembly language to the mic. Couple of things, I always draw inspiration from nature. Anything large you want to build, complex, just to be build of atomic things, which are elegant and small. Look at how we are built. The fundamental building block is a cell. A cell has built enough resilience in it. Okay, cell multiplies, divides, and cell dives, has a life cycle. And you have cell micro, so just think of a microservice as a microorganism, which is self-contained, independent, autonomous, and distributed. Whole world, the universe works in an autonomous, distributed, independent way. If you don't adopt the tone, I have seen people design microservices. N number of microservices there, they go and access the same schema. Yeah. Fundamentally, does a cell depend on another cell? There's a clear, just start studying a little bit of biology. All we want to solve in the microservices world is already solved by nature. Just start adapting it and using it. You'll do wonders.
Right, and I think apart from all the good benefits about it, I think it is more about loose coupling, high cohesions, creating autonomous systems. I think that is really a great. Now let's talk about, we talked about microservices, right? Let's jump out into the another topic, which is all about cloud, right? Cloud is a new normal, right? Or I would say probably a hybrid cloud is a new normal, right? Now, as an architect, right, you end up not just seeing all the complexity of the business which has been driving, but you are also being bombarded with different hyperscalers, which is really coming out. So, Priya, I think the questions for you, just to get started it out, is what are the skill sets that you think the architects needs to imbibe in order to create an architecture for a cloud native applications as such to proceed it forward?
Yeah. The term cloud has been around for more than a decade now. Industry started off with cloud migrations, cloud adoption, then we moved on to the likes of hybrid cloud, distributed cloud. There was a lot of hype about those. And now, industries are again moving towards a cloud native way of doing things and cloud verticalization. And there about 30% as per analysts and the industry stats, reverse migrations are also happening. Cloud migrations and then reverse migrations back to data centers is also not uncommon now. 30% of the enterprises are even looking at reverse migrations, and that's the understanding what is key to success and what's really critical with to succeed with cloud native way of functioning, and for the relevant architecture skills. What's really important is the reason for adoption of cloud. It's agility, scalability, faster response. These are the core premises of migrating to cloud. And if those are not kept in mind while doing the architecture and design of your cloud systems, the whole premise would fail, and that's where I definitely have seen the reverse migrations happening. What's critical is not to replicate your data center on the cloud. The whole premise of cloud is that you go serverless. You depend on platform as a service, more and more platformization than going on creating servers. That's one critical aspect when you're going cloud native. What's really important. Number two is process. It's process. Very, very important in terms of how you spin off new machines. Process which cannot be violated. Creation of shadow IT. How do we avoid it? How do we do continuous monitoring? How do we do continuous cost verifications? That's why I was saying earlier also, cost consciousness is very important. Close monitoring of all these aspects, and now there are a lot of tools available as well, and most of the cloud platforms offer them cloud native free of cost. Your CSPM, CPM, CNAP, there are many kinds of tools available to keep close monitoring of it, and this should not be an afterthought. It should start from the beginning. The day we adopt cloud, all this monitoring and controlling and process orientation has to start immediately. And a third aspect definitely is automation, as much automation as possible. That's another reason why cloud adoption or cloud native is coming into picture. Move away from the typical way of doing things in a data center, automate as much as possible. Like I said, your process, monitoring, provisioning, including code development, everything can be automated. So very keen focus on automation and building it into all cycles of your cloud migration adoption, once again, is very critical. And then of course, security. For cloud native success, security is very important because everybody, including the data owners, your customers, everybody is worried about their data privacy. How we secure data, very data-centric focused security. What is critical on the cloud? What are we storing? How is it secured? Clear articulation of data privacy and data-centric security is very, very important for the eventual success of your cloud native journey.
Oh, very great points, right? Srini, your thoughts?
A couple of things, I'll just tell you two perspectives. One as a cloud user and as a cloud service provider. Okay, two aspects, right? So I just seen people, have been doing lift and shift. Unfortunately, if you just look back history, we went from physical machines to virtual machines. Shortcut, actually, a shortcut, okay? Applications were never designed to be virtualized, but somehow P2V came in, it's a shortcut, people did it. Now, a lot of cloud migration fails because you're trying to do the same thing, lift and shift. Because cloud comes with a different kinds of, benefits, features, and you also need to put a governance model in place. I'm surprised by something called a FinOps. FinOps is like an injection for not having governance in place. Yes. So fundamentally, when you want to do cloud native, you better have proper governance in place. When you have governance and tools in place, I think, cloud native will work, right? At the same time, one has to be, again, little aware, because every cloud operator trying to be more native feature. So we just look at 3 cloud vendors. It's nothing but a three monoliths, right? You had a HP, IBM, Sun, right? It's a new avatar. It's 3, okay? So you have to make sure that you build solutions which are cloud agnostic. You have to exploit the features of native, at the same time be agnostic. So you need to think about exploiting the cloud native features, at the same time be agnostic, because multi-cloud is a reality, right? You need to exist on multiple clouds. You cannot rely on one cloud vendor because we have issues, geopolitics. So we need to be aware of all these things and design your cloud solution with governance in mind, multi-cloud in mind, and then probably you'll be successful in that endeavor.
Yeah, I think governance is really the key, which is very important. Cost is really the key, because certainly lift and shift is not going to be the easiest stuff. And I think, personally, I feel that there might be a slight downfall in the cloud adoption, because lot of already an application has already moved to the cloud. Then it needs to be business driven, and it has to be levers that really provide a great ROI in terms of the adoptions. Then only it will move out. So tentatively, this is the way it needs to get posture. But certainly, some of the skill sets that you really mentioned, Priya, makes a lot of sense along with what Srini has mentioned. I think this is really good. So we spoke about microservices, which was the one stuff that we talked about. Then we started speaking about, initially we touched upon AI, ML, and then microservices, and then we talked about the cloud. The other thing that comes to my mind, which is really important, is low code, no code. I think everybody is talking about it, right? All the hyperscalers are coming up with low code, no code platforms and all. Now, there has been some sort of challenges with using low code and no code, in terms of getting the control over it, getting, the complexity it brings it, rather, find the grain of control. But there are a lot of opportunities as such, because speed to market is always the key. So Srini, for you, my question is that what are the opportunities that you see by leveraging the low code, no code, and how can, as an architects, right, these architects can really benefit from utilizing the low code, no code developments?
I think you touched upon quite a few things there, Nishit. Whatever we do is the time to market or help businesses to function faster. Or if I take Raji's words from the morning, the feedback. So the whole technology is about shortening the feedback loop from what happens on the ground and what I need to do first, right? Or to reinvent your products or services, whatever it is. Now this, historically we have been developing, you spend, I think we heard 9 months as a timeline for a banking system to go back, but in another like Flipkart or e-commerce one, we heard 14 days. So the low code, no code is the one which is really shortening these timelines. And second, it is the one which is probably eliminating the distance or IT side and business side ones. So now this is the weapon given to business users to really solve their problems on their own. Now, this is what we all probably heard about the citizen developers to really solve their problems. But yes, Nishit, as an architect, would I be happy with it? No, it will give me nightmares and jitters. I don't know what kind of applications each user is putting out there. Then who will end up managing them? How it's going to create impact on my overall enterprise IT landscape or system landscape? So I would probably try to look at, whenever I open up such a platform, an organization need to be clear on what is the purpose of these platforms. What kind of problems are allowed to be solved using these LCNC platforms, and who will use that. So then probably the practices which we follow, we typically end up creating two zones. One is those zones where these LCNC applications are put up for a given functions or horizontal functions. And typically people again use this for personal productivity tasks. So that we should let go, and people, they can have their own personal productivity tools in their own spaces, and they won't impact my overall landscape. Then second aspect, how do you really take care of, this will not severely impact my overall backbone. I would really put in governance methods or the kind of data and APIs, data models and APIs to open up for my citizen developers to consume and develop their own apps. If I don't open up, then they can't really do that. So here is where I have kind of a governance model to really see, I wouldn't often open an API which would enable somebody to probably query a whole lot of data or would put unwanted load on my systems. Then third, I would also use a different perspective to periodically audit all these applications and see, hey, which are the problems which my application is not solving, which is really forcing my functional users to solve on their own. Probably that's a arena for me to pick up patterns and see what is my next cycle of application enhancements to be done. Finally, I would not allow or recommend anybody to put in a lot of logic into these things. When you end up putting a lot of logic, then it will become a nightmare for anybody to manage. Yeah. So these are some ways, typically you can have kind of governance. At the same time, I'll give the required freedom for really business to explore these platforms and solve their problems.
Yeah. My general sense about, the low-code, no-code is, apart from all the productivity benefits, I think the challenges are a lot more, right? Of course, we have created loud architecture network. For me, the performance is really the key for now while we are building the systems, right? So performance has always been a challenge. And the bigger challenge is that I'm having a vendor lock-in, which is really one of the things that needs to be key. So as a guidance that I can always give it out to our architects is that you need to talk about these two things. So tools needs to be very appropriate if you are really going for a low-code and no-code options. And the second thing is that governance, right, which is really very, very important. But then the two considerations that I mentioned about the vendor lock-in and the performance, that needs to be achieved, right? So don't really get swayed with the low-code, no-code platforms, right? Because every one of us has came out from building codes, right? So it is better, right, just to avoid it, not go for these all stuff. So we spoke about low-code, no-code. Let's talk about like event-driven architectures, right? You gave an example of a click. That example, I think that just made me thought that we should talk about event-driven architectures, right? When there is an event-driven architecture, what are the skill set? What are the key criteria that architects needs to be considered to really create the composable architectures of Gartners of the world today, right? So Vijay, if you can just share it out, right? You are talking about 400 microservices and other stuff that you have done. I want to just understand, how you are just trying to do it out for the event architecture.
Yeah. So I think event-driven design pattern is a powerful tool. We have to be careful about what use cases and scenarios it's actually applicable for. So for example, at Swiggy, once an order is created, which is the payment transaction goes through, the entire orchestration from when you see that the green check mark saying the order has been received, till the food or the Instamart grocery item shows up in your desktop is entirely orchestrated through event-driven systems. So we use a paradigm called choreography, which is essentially a model built on top of a shared event bus. And one of the benefits of this is that it allows for a very loosely coupled architecture, especially when you are operating a marketplace. See, typically when you're operating a marketplace, you have multiple independent actors, all of whom are taking actions. For example, when you place an order, we have a system called assignment, which is trying to find the best driver for that particular order the customer placed, depending upon the customer's location, restaurant location, etc. And then we have a set of systems that is actually interfacing with the restaurant or the pod, if it's an Instamart order. And then we have systems that are actually interfacing with drivers. Now, the advantage of a choreography pattern is that all of these domains are acting independently. And they only talk to each other using some shared contracts as events. The downside here to be very careful about is sometimes these event contracts tend to be tribal knowledge or verbal knowledge that gets shared across teams. So having a schema registry and a strongly typed schema is going to be very important, because when a company rapidly grows, this is not a concern. But when you start operating at scale and doing millions of orders a day, even a simple contract mismatch between these domains in an event-driven architecture can have catastrophic consequences. But of course, it allows us to sort of more independently design and develop systems and make changes. For example, if the vendor interaction systems change, nobody else needs to know about it. And only that subsystem participates in the choreography will have to modify. The other learning that we had through this event-driven architecture journey is this concept of a split brain, which is that sometimes your systems, because they are so loosely coupled, there is a possibility that two different domains have contradictory views on a particular source of truth. Right now, if you have one giant brain, which is an orchestrator, you wouldn't run into a situation like this. But in a event-driven design, you have to be very careful about this. And typically, you solve this by defining attribute boundaries very carefully. So if you're, depending upon the type of question you're asking for the same entity, you will have to identify sources of truth that are qualified to answer the question, because everybody is listening to everybody's messages in an event-driven design. And it's possible that they are kind of tracking state independently. So these are some of the learnings for us, but overall I think it has been a very, especially for this leg of our architecture, I think has been a fantastic solution for the problem we have.
And my thoughts are certainly on your lines, but I think just to keep it simple, right, they are event design principles, right? So, you have to follow that, right? And consistency, data integrity is very, very important. And I think when we are really doing an event-driven, I think there's a potential for doing an over-engineering. And this is one of the things that, as an architect, you need to really think about, that you are not over-engineering the stuff while really, creating the, event-driven design and any of the application as such, right? Let's go to Priya and talk about, software industries, right? What are the key trends that you are seeing over the next few years from the software industry, right? Where do you see the software engineering going over a period of time in the next few years, right? And how does, as an architect, we talked about all the skill sets that they talked. Let's talk about the technology as such, right? From the technology perspective, right, there are plethora of technologies that are coming, right? And everybody is a technical guy. Of course, we always keep on saying that, hey, you need to be, technology agnostic from the architecture perspective, which is great. But of course, the mindset is always, because that's how we have been brought up. Maybe a .NET guy or Java guy, they have been thinking about that perspective. Now things have changing, right? So what technology they should really learn in order to embrace these all plethora from the technology perspective? If you can just share your thoughts from the architect, I think that would be great.
Yeah, I'll focus more from an architect perspective, because the development skills that you look at and the platforms that you work on, they undergo changes every 6 months. That's the kind of world that we live in. But what are the trends that are going to rule the industry for the next couple of years is what I would really want to highlight. First thing is, in last decade has always been about cloud first. Every organization was looking at cloud first. But now we are, the next decade will probably be ruled by a new concept of industry cloud first. Cloud is getting industrialized. Everything above platform onwards is going to get very particularly aligned with an industry segment. To that effect, you can already see that the likes of Microsoft and AWS have launched multiple verticalized platforms. Salesforce is getting verticalized. The service providers are getting into vertical alignment. So that's going to be a key trend, which will kind of burst all the myths that we have been working on so far. We were thinking from a platform and serverless and provisioning and development and app modernization. Those were the common themes that we were thinking at, but this is going to kind of completely bring in a shift. That's a huge shift for many role perspectives and job perspectives, but the faster, the sooner that we all align, especially the architects, that would definitely prepare you better for what's going to happen next. And once again, another huge shift that I've already seen in the last 1 year, and kind of my own work is significantly aligned in that direction for the next 3 to 4 years, is we've seen infrastructure going to cloud, we've seen applications and data, all aspects of data centers and business going to cloud, and now everybody is focusing on taking their IoT and OT devices. That network has completely been physically separate so far, but that's not business efficient anymore. Everybody is focusing on how to take that, how to modernize that, and take it to cloud, SaaSify that. That's going to be a big trend, especially industries such as healthcare, pharma, manufacturing, oil and gas have huge estate lying out in their manufacturing and R&D sites, and that's a completely physically separated network. There's a lot of work that's going to happen in the next couple of years, which is focusing on those areas, your segmentations, and I've recently worked on a huge SCADA migration to cloud, which is for a public sector organization. Governments are looking at it. That's a huge trend once again, something to definitely focus on. And a third aspect which never gets old, areas that I already talked about. Your focus on AI and automation and data privacy, they're not going to go anywhere. They're also going to get modernized. What we do in those spaces will get modernized, but they're always going to say, these are the skills to definitely adopt and to stay ahead of the curve, definitely.
Yeah, thanks. Vijay, you want to share your thoughts?
Yeah, I think for those of you who've been around tinkering with 8084 architectures, I don't know how many of you have actually programmed in some of those. You will notice that every 10 years or so, give or take, there are fundamental changes to the compute paradigm, the so-called one Neumann architecture that was very prevalent in the early stages of the software industry going up. And then you had, as I think Srinivas talked about, P2P migration. Virtualization was another kind of a stepping stone where we were able to actually do multiple workloads on the same physical infrastructure. The cloud evolution sort of was the next stage there, where you can think of it as a distributed operating system. So an operating system is able to manage hardware on a given physical entity, which is a processor, disk, memory combination. And then if you look at the cloud evolution, roughly speaking, it's a distributed operating system that is allowing you, is basically giving you a higher order abstraction. What I find is a lot of the new engineers, when I ask them, do you understand what the difference between a file and a socket is, they just look at me as I'm talking Greek or Latin, because a lot of them have grown up with the JVM abstraction. JVM abstraction has actually taken away what the underlying machine architecture does. And likewise in the cloud-based or in function as a service, etc. So the transition I'm seeing really is from software engineering to software assembly. It's not going away. It's not going away. So there are going to be a class of engineers, a small tiny class of architects that are actually going to specialize in ensuring that operating systems can deal with hardware in a very efficient manner, but that's going to be a very niche subset. In fact, there is tremendous scope, I think, in optimizing operating system for GPUs. I think it's an extremely unexplored territory right now. While that's happening, most customer-facing applications are going to be assembled. So now the question that you need to ask yourself is, if I'm going to be doing assembly, how do I develop skills that's going to give me the ability to quickly identify the right building blocks? Okay, because the building blocks themselves are so complex now. The building blocks themselves, even the object storage as an abstraction is very complex. It has completely taken away the concept of file system away from developers, correct? They don't know what a file system is. They don't know what a VFS is, because object storage has taken away that complexity. Now, if you are putting together a customer backwards application, an enterprise application in any industry, I think you have to have the ability to quickly identify what are the right building blocks And this is a skill where you're going to have to stand on the shoulders of giants. Unfortunately, it's gone are the days where you can. I remember the days when I actually ended up writing my own memory manager because I didn't like the way glibc was handling memory for my application. I mean, I don't think that option exists anymore. So I think this transition from engineering to assembly is what I would call it as a highlight, where I think you need to really watch out for how you can be effective.
Yeah. See, I remember, one of the sense, right? Bill Gates once said, "It's okay to be confused for a while," right? So when I started this stuff, right, basically, COBOL and other stuff, right? You were saying, yeah, this is fantastic stuff. That the word of, .NET came in, and I did this all .NET stuff all together, right? And I said that, yeah, this is really great. You just know this technology and you are done. And and now, of course, who talked about .NET as a skill set? It's a skill set that you are competing with the college freshing graduate. So the way how I really suggested out, while there are a lot of technology which is coming out, the way how I perceive from the skill sets is, you just think it out from the hyperscalers or the companies, how they are strategizing. And then, you think about, where you want to stretch. And that is where, that is what I have been, spending a lot of time from the SPUG. For example, let's take a case of IoT, right? Everybody is very familiar, right? My sense is IoT has two main things. One is intelligence and second is things. Now you see a lot of companies who are in the area of intelligence, right? So you would see the companies like Google, Microsoft of the world, who is on the intelligence, right? The AI of the world, right? And then we have the companies in the things area, like you have Bosch and other companies who are Qualcomm and all of those, which is things. Now there's a great intersection which is happening, right? The companies who are into the area of things are actually trying to come into the area of intelligence. And you would see, the software companies are buying the hardware and hardware companies are buying the software. And you will say that why, Google is buying Fitbit and other stuff. Of course, this is the reason. Because this market is so much tough, right? And creating the next generation application is the key to having interactions about where the intelligence and things can really merge and combine. That is probably, one of my guidance, right? Because I feel that this is one of the area which is going to be really developed over a period of time. And that is what we need to embrace, right? So I think that is what I want to, share from my thought and my perspective. And now we have around 6 odd minutes, so we can really ask questions from the audience, right? If there are certain questions, right, definitely we want our panelists to answer. Go ahead, please.
Why don't you see semiconductor way of computing needs to have a revisit and thought of. Can you speak? Yeah. So can you hear me? Yeah. So morning we speak about sustainability and the energy contribution, energy consumption associated with that. Now I just wanted to understand, like when Srini was saying about doing his own memory management coding and all, right? So the future computing, should we even think about moving away from semiconductor way of computing? I think that's where the energy consumption as well as all the modern architecture complexity is coming around. So how do you see around that? Should we even discuss that as a future trend?
Yeah,
is there an alternate for it?
Yeah, so I would slightly rephrase that as saying not the semiconductor way, but I think the compute model. I'll give you one quick example of what we saw. We migrated about 40% of our workloads from x86 architectures to Graviton. We saw a 20% increase in latency. Sorry, 20% reduction in latency for microservices. And a 30% reduction in CPU. Tell me what are the transition is going to give you this kind of a benefit curve, right? And the reason is that certain architectures are amenable to certain types of processing that you do. If you have a heavily IO-bound workload. So back to your sustainability question, I think that the compute paradigm itself is shifting. Like I said, right, you've got x86 architectures, you've got RISC, and now you've got GPUs. We really need to figure out efficiency gains in the way the software applications are designed, the underlying libraries are designed so that we can more efficiently. The problem is we tend as architects to be 2 or 3 levels abstracted from the machine. And as long as you're abstracting the machine, the talk of sustainability is just huffing and puffing. Because you don't understand the power consumption characteristics of processors. If you don't understand power consumption characteristics, how are you going to make it more sustainable, right? So I think that's just my thoughts on that. I mean, you want to add?
Yeah,
Maybe add a couple of things. My focus has been long-term, last decade or so, only sustainability. Just while we are rapidly digitizing, one of the things we have forgotten today. We always thought, that airline industry was the most polluting. Actually, today the digital industry is the more polluting. More pollution in terms of CO2 emissions than the aviation. Okay, just your endpoints, your desktop, smartphones consume more than 1.1% of the global energy. Aviation consumes less than 1% of it. So we have made optimize it, but at the same time, we are actually what's happening is that there is a digital revolution happening. At the same time, it's unsustainable. Look at today the amount of water consumed. See today, I don't think people who write code understand it. I want to create the awareness. Just to give a simple example, right? What have you think about? I always say, as a country, we have to be frugal in our resources. What we have today. To produce 1 kilowatt hour of energy using nuclear or coal, we consume 95 liters of water. Go back home, turn off things, 1 kilowatt hour, one light running for the day. Even a computer, a desktop running for a day. Actually, today computing power is more than light. LEDs have become optimized. But so one of the things what's happening is computing is evolving at the same time, becoming more and more powerful. So we are building more complexities. Okay. So future I will see is one is creating awareness, creating sustainable architectures. At the same time, understand the limits. I think computing industry, the digital world, we have been unconstrained in terms of money, many things. We have been, say, blue eye on the block, right? I think we have to be a little more aware and conscious of all the things. The IT industry has to take the next ownership. You cannot blame the oil and the aviation industry. We are the biggest polluters in the world today. We create massive amounts of e-waste. Every time you write a piece of code, all of you, think about what's the impact, right? I've seen people writing microservices with 64 GB of RAM. It's nonsense, yeah. You don't write, it's not meant to be that, right? And are we efficient? No. Do you know what's the power of a human brain today as beings?
So should it be always zeros and ones? The computing shouldn't be in bits.
Look at different parameters. I think, see, when Intels of the world say we're efficient, I said you're no longer there anywhere efficient. Human brain, the complexity of human brain is so much. A mainframe, a computer filling this whole building can do as much as human brain, but human brain consumes only 16 watts of energy. So we are far away from the natural efficiency. I always say look at nature and how can be more efficient, right? We are far away from that. Thank you.
Thank you. Thank you.
I'll just one very light question. First of all, thanks a lot. I mean, really in depth, but I want to just lighten up a little. But it's very relevant because this is about embracing latest tech, and you said trust, right? Some time back, now in our office we have a system. Okay, that system is used by everybody. It's a conference room, right? So I use that often for conferencing, stuff like that. So one day I started and I was doing something. It's very, very slow. So I just called the tech support person. What happened? Right? I'm just hear this conversation. He said, "Oh, sir, actually this system got upgraded from Windows 10 to 11, and that's why." So I said, "Oh shit." I mean, but it's such a natural conversation. It's got upgraded, therefore it is slow, and even I didn't feel, oh, that's the problem, right? Now, so on one hand, we are talking this, and of course, you were saying that the difference between what's hardware and, but for architects, what is the lesson here? I just wanted to pose this.
Constraint is everything. Let me just give you a simple example. Aadhaar, right? When we are building the Aadhaar system, right? I think few of us sat for 4 or 5 days to model the whole system, model for in terms of everything, compute resources, space, power. Will you have power? Can the grid in Mysore, in the Bangalore, can the KEB deliver the power? So if we had gone by the traditional architecture where the biometric systems were built in the world, we would have probably needed 100,000 servers, tens of megawatts of power, which was unsustainable for the country. We needed $50 per enrollment. We ourselves set a goal. I want to do with $1 per enrollment. Three to 6 months we worked on changing the algorithm, fundamental algorithm we changed, we reworked, and today the Aadhaar consumes less than a megawatt of power. We have to cut down by order of magnitude to make whole thing sustainable, economical, and at the same time impact on the industry. We calculate the carbon footprint, we calculate the network bandwidth, the building space. Pretty much, I think architects need to model everything end to end. The business, social impact. Because if you look at what nature does, nature creates everything which is sustainable. Why can't we imbibe nature and look at the impact on everything we do, right? Could be water, could be air, could be everything. If the architect takes a nature's view, I think we can create sustainable, everlasting solutions.
See, I want to answer it, but I think Dr. Padal has some pointers that I want to ask.
I just had a comment and a couple of observations, especially on the skill set perspective, which you covered earlier in the first half of your session. Generally, one of the skill sets that architects lack in India is the interdisciplinary skill. Like you said, we need to learn from biology. Given that most of us have a degree in engineering, we never studied biology after class 10, right? What I've observed is in the Western countries, most architects have a non-engineering degree. And I can mention John Zachman. I'm sure many of you have heard of him. I've co-authored a book with him. He has a degree in economics. So that's kind of, in a way, we are limited. And that's the reason why most of our architects, they still tend to think like engineers, because they are engineers by training. The difference is an engineer has to work with black and white. You have to have all information before you build something. If I build an Airbus A380, I need to be ensuring that that is a reliable plane that takes you safely from place A to place B. Architects need a different skill. They need to be comfortable working with incomplete information, working in the gray. Right? With your permission, right? Somebody like Rajendra has to take many decisions during the day, even with incomplete information. Otherwise, you will never be able to act. Oh, I'm waiting for the information, let it come, and then we will see, right? That does not happen. So this is a very important skill that architects need to embrace, irrespective of what technology you use. And that comes back to the social skill and all that stuff. So I thought I'll just mention that.
And then the last stuff, right, from the skill perspective, right, and we will sum it up, right? We talked about IoT and the sensors, right? You know that, 70% of the sensors that there are in the world are not able to run the AI models, right? And so what we should do? So, and that is where the AI accelerators comes out, right? And that's where we really deploy, so the likes of Qualcomm and all are really building the AI accelerators as such, which is really a huge market opportunity. So I think that is going to be the next, probably for me, is the next big thing that you will see. With that, thank you so much for